I'm Balan Subramanian, and I lead the product team for Azure App Platform. Azure App Platform focuses on frameworks, services, and ecosystem that enable different application workloads on Azure. With Java being the language of choice for millions of developers, we have specifically focused on making Azure a great platform for Java applications of all kinds. Today at Build, I'm excited to share the broad support we have for Java and Azure and show you some of the unique capabilities we have built to enable Java applications and developers. And I'm also eager to show you how enterprises are building amazing Java applications on Azure. Java developers care deeply about platform reliability, performance, and support for the broad ecosystem around Java. They want a trusted platform that provides native integrations for the frameworks and the middleware that are important to them. Azure is available in more regions worldwide and has more certifications than any other cloud provider. And Azure is the only platform with fully managed hosting options built exclusively for Java. You can also leverage Azure services for multi-cloud applications that span different clouds and on-premises. It's no surprise that Azure is trusted by more than 95% of the Fortune 500 for their mission-critical workloads. Enterprises run their business-critical apps on Azure. Customers of all sizes and industries are building and running different kinds of Java applications on Azure. For example, Starbucks has built and runs various Java applications on Azure to power their retail and backend operations. Best Buy is using Java functions to scale to the demands of their business during the busy holiday season. And Kroger is using Azure Spring Apps to manage inventory across hundreds of grocery stores. I'm really excited to showcase one of these customers, FedEx. FedEx is a household name that millions rely on. Let's see how they use Java and Azure to power innovative and useful digital experiences for people everywhere. FedEx launched several cloud applications fueled by data to create differentiated value for their customers across industries. These applications run at cloud scale and integrate back into on-premises data center. One such application is Global Delivery Prediction Platform, or GDPP. This application dynamically predicts the estimated time of arrival for shipments and has a huge impact on customers with time-sensitive deliveries. Given the volume of shipments, all the parts of this application need to operate at cloud scale with high reliability and availability. Azure Spring Apps is a primary compute for processing high-volume messages for GDPP. FedEx chose Spring Apps because of its ease of use and auto-scaling capabilities, and the fact that it is a fully managed service. The tight integration with other Azure services also enables FedEx to move quickly with confidence in building and delivering the application as part of their worldwide web presence. That was a great example of how Azure enables you to build globally available digital experiences where you can focus on your application and rely on the platform for reliability and scale. Whether you're using Spring, like FedEx, or any of the popular Java frameworks and application middleware, Azure supports them natively with tight integration into the rest of the platform and partner services. And you can implement any application architecture, from monoliths to containerized monoliths, all the way to completely microservices-based applications. We are committed to enabling any Java app, any app server, and any framework across the spectrum of infrastructure, containers, and fully managed PaaS on Azure. Depending on how much control you want over managing infrastructure and the level of productivity you desire, you have several options for your Java applications on Azure. You can lift and shift existing Java apps to virtual machines. You can containerize your apps and run them on generalized container platforms such as Azure Kubernetes Service or Azure Red Hat OpenShift. And our unique platform as a service option provides ease of use, ease of management, developer productivity, and operations efficiency, leading to lower total cost of ownership. We see customers everywhere using containers to modernize their Java applications. Many are attracted by the flexibility offered by Kubernetes, but managing Kubernetes can be difficult and expensive. Azure provides the best support for Kubernetes through Azure Kubernetes Service and Azure Red Hat OpenShift, both of which reduce the cost of operating Kubernetes yourself. And Azure Container Apps provides a fully managed serverless container service for deploying containerized apps without having to manage any infrastructure. These Kubernetes-based platforms are fully integrated into the tool sets that Java developers are familiar with. They are also fully integrated with a range of Azure services. With these integrations, you can use Azure RBAC for access to your Kubernetes cluster Azure Active Directory for end-user authentication and authorization, and Azure Key Vault to securely manage your application secrets. You also get built-in security monitoring with Azure Security Center and out-of-the-box observability for your infrastructure and applications with Azure Monitor. You can also use Azure Arc to manage your Kubernetes environments and the platform services that you use across clouds and on-premises. Azure is also unique in that it offers fully managed PaaS for different kinds of Java applications. App Service offers a fully managed PaaS for deploying Java applications to Tomcat and JBoss EAP. Simply deploy your var or year files, and everything else is taken care of for you. There is no need to worry about infrastructure, patching, or implementing blue-green deployment strategies. JBoss EAP in App Service is jointly built, operated, and supported by Red Hat, and we will hear more about this unique platform service later in this session. Spring is very popular among Java developers, and it is the framework of choice for building cloud-native applications with microservices. Azure Spring Apps is a fully managed PaaS built on top of Kubernetes. Capabilities such as service discovery, centralized configuration with a Git backend, and distributed tracing are all available out of the box as part of the platform. This removes the need for you to operate these critical pieces of infrastructure yourself. It also provides an application lifecycle management experience that is familiar to Spring developers while leveraging tight integrations into Azure. With this service, previously known as Azure Spring Cloud, customers such as Kroger, Liantis, Morgan Stanley, FedEx, and others are able to focus on building innovative application experiences instead of spending their valuable resources on managing and scaling infrastructure. We are announcing a new name, Azure Spring Apps, for this service to reflect the range of Spring workloads that customers are running on this unique platform. And continuing our partnership with VMware, we now operate components of the Tanzu application platform as fully managed capabilities within Azure Spring Apps. We will dive deeper into Tanzu in Azure Spring Apps later in the session. In addition to providing a great platform for running your Java code, Azure provides various managed services to support your data and messaging needs. These include Azure services such as Azure Database for Postgres, Azure Cache for Redis, and services such as Confluent and MongoDB Atlas that are offered by our partners on Azure. All of these services provide the compliance, availability, and reliability guarantees that you would expect from Microsoft and Azure. And regardless of whether your apps are running on VMs, Kubernetes, or PaaS, you can quickly provision and leverage these fully managed services with open source clients, Azure Java SDKs, Spring Starters, and App Server integrations. We believe deeply in partnerships to bring the best capabilities in the ecosystem to our customers. We are working closely with various partners who share our commitment to nurturing the Java ecosystem. And we're using different partnership models to bring the best cloud platform to Java developers. Azure natively supports many flavors of Linux that Java developers use today. Together with Oracle and IBM, we have delivered fully supported solution templates for their app servers on VMs and Azure Kubernetes Service. There are hundreds of partner services available through the Azure Marketplace for Java developers. And some of these services are operated by our partners on Azure and natively integrated into Azure, allowing you to provision, use, and manage these services just like any other Azure service. And we also have first-class services such as Azure Cache for Redis, Azure Red Hat OpenShift, JBoss EAP on Azure App Service, and Azure Spring Apps, where we jointly operate the service with our partners' expertise and support. Before we take a closer look at what the platform can do for you, I want to highlight some of the key announcements we made at Build that are particularly interesting to Java developers. To start with, you can now leverage the efficiency of ARM architecture for your Java workloads on Azure. VMs with ARM-based processors are now available for you to use directly or in Azure Kubernetes Service. We also announced the public preview of Azure Managed Grafana, a fully managed service for Grafana dashboards that we're bringing to developers on Azure in partnership with Grafana Labs. We're also making Nginx and Dynatrace available as natively integrated services on Azure. These services are operated by F5 and Dynatrace, but you can provision them, use them, and manage them just like any other Azure service. And I'm really excited about the general availability of the enterprise tier of Azure Spring Apps. This service brings the best of VMware Tanzu and Azure together into a fully managed platform for cloud-native applications. Now let's dive a little deeper into Azure Spring Apps and Azure App Service for Tomcat and JBoss EAP.
Thank you, Balan. I'm Asif. At Microsoft, I'm on point for everything developers need to build, migrate, and scale Java apps on Azure. I'm also a Java dev. I started in 1995 with JDK1, and I've been having an amazing time with Java ever since. Today, we're going to talk about Azure Spring Apps. Azure Spring Apps is a fully managed service for Spring Boot apps that let you focus on building and running the apps that run your business without the hassle of managing the underlying infrastructure. On the slide, you see the rectangle. It represents Azure Spring Apps. It's built on Kubernetes. Each service instance has 2 dedicated Kubernetes clusters. They are managed by Azure Spring Apps and abstracted away from users. Service runtime with managed Spring Cloud components, app lifecycle, log streaming, and many more service runtime components are managed in the right side Kubernetes cluster. Your apps are running in the left cluster in the diagram. Your apps can interact with any Azure service or external service or on-premise systems. Logs, metrics, and alerts are available through Azure Monitor. You can monitor end-to-end using any tools and platform of your choice. You can secure your apps using Azure Active Directory. You can automate end-to-end using tools and platforms of your choice. You can continue to use development tools that you are familiar with, whether it's IntelliJ, Eclipse, VS Code, Maven, or Gradle. You can also deploy using tools like IntelliJ, VS Code, and Maven. Net, it's an easy way for you to get started. You can focus on your business objective, and everything else is just taken care for you in the cloud. Now, do you have to manage anything here? No, you don't have to. Azure Spring Apps has absorbed all the complexities and infrastructure, hosting applications, app lifecycle, managing applications, blue-green deployments, publishing logs and metrics. The list goes on and on and on. Everything, all are supported by Microsoft and VMware for you. Azure Spring Apps is as simple to spin up as it is powerful, and it follows 3 simple steps. First, create a service instance. Next, create an app within the service. And finally, deploy the application binaries or source to Azure Spring Apps. Azure does all the hard work for you. All you have to do is point it in the right direction. It is really that simple. Now, once your apps are up and running, they can connect with Azure services. We have made it possible to leverage the full power of Azure from your Spring Boot applications. And it's getting easier to do so every day. Our engineering team is focused on these integrations, and we continue to improve them. We provide mechanisms to connect and interact with data, messaging, cache, storage, directories, and so much more. Enterprise is the new tier and is generally available. Enterprise delivers even more productivity, and you can leverage Spring experts to make your projects even more successful. Tons of components provide new capabilities designed for enterprises running Spring applications at scale. Today, we will show you some of these features in action. You can deploy and manage Spring applications and polyglot applications built using Node, Python, Go, and .NET. With the fully managed Spring Cloud Gateway, you can route any client request to apps and address cross-cutting considerations for those apps behind the gateway. Cross-cutting considerations like configuring single sign-on, using your preferred identity provider, including Azure Active Directory, or considerations like request rate limiting, and so much more. Support and export guidance for Spring projects let you focus, develop, and deploy applications faster. Candice is here with us, and she's going to show us a demo.
Hi, my name is Candice Quates, and I'm an engineering manager at VMware. I'm excited to show you Azure Spring Apps Enterprise tier. Okay, let's get started. I'm going to use a fitness store application to illustrate some platform features here. To demonstrate that, I'll be ordering a few things. Let's look for our bicycle. Here's one. We'll add it to the cart. Next, I want a water bottle, so let's add that one to the cart too. Hopefully it's insulated. And go to our cart and see all of our items and proceed to the checkout. Add an address. Done. Choose a shipping speed. Sean's tractor. Add a credit card number. And continue to review and hit place order. And it succeeded. Great. Here's the Azure portal where this Azure Spring Apps deployment is running. You can see the tons of components on the left side. And here are the apps that make up our fitness store, like the catalog, the front end, and the cart. The repository for this application is hosted on GitHub, and it has detailed instructions to get started. You can do everything I'm showing today by following the instructions in this repository. Now, I also have this open in VS Code. Here's one of the Spring Boot apps, the Catalog Services Controller. I also want to show the front end, which is written in JavaScript. It's a Node app. It runs in Azure Spring Apps too. Now, this is a common app architecture that we're all familiar with. The sample app has a similar architecture with multiple applications, a gateway, a database, security services, monitoring, and automation. We support many different languages and Azure services. Let's start from scratch and create an Azure Spring Apps service instance in the portal. As you can see, we already have Enterprise tier selected, and we've chosen a name and a region. The Tanzu components are here, and support for the entire Spring runtime is included. Tanzu build service is included by default as well. The rest of the components can be added and configured as needed. Service registry, app config service, Spring Cloud Gateway, and API portal. When we're done here, we can go to the Review and Create button and see what we've selected to create an instance. Now let's go to the Azure CLI and create an app for our payments. There we go. After this is created, we can deploy a Spring Boot application into this payments app container. So let's deploy command here. And what this is doing is it's uploading our sources and building a jar. Then it's putting the jar in a container and deploying that container into Azure Spring Apps. So it's almost there. Building, succeeded, updating deployment, all right. We're also going to create an app to hold our front-end deployment. It's written in JavaScript. In the deploy command, we're going to upload source files. Tanzu build service will apply Node.js build packs to build an image in a container and deploy that. We're also going to configure Spring Cloud Gateway to route traffic to the front-end app we've just deployed so we can see everything. Let's open the Azure portal for our apps. Over here, we should be able to see 6 services running. Yep, there we go. And we can take a look at Spring Cloud Gateway's routing rules. You see the cart here, and if we scroll down a little bit, we'll be able to see the rules for the catalog. And we'll go to the main gateway page and jump into our application just to show that it's all running. There we go. Here's our stuff. This is API Portal, and it's showing all the routes that are set up in our instance of Spring Cloud Gateway. Here's the cart and the catalog, for example, the route for the front end, which just goes everything, SSO and the users. Let's choose the catalog to show how to test an endpoint. Let's click Products and hit Try It Out, and then Execute here. Scroll down, the request succeeded. And if we scroll down a little more, we can see the server response. And we got a yoga mat here that can make you an instant professional with barely any work. Awesome. We started from scratch, deployed our apps, created a database and connected the apps to it, and configured Spring Cloud Gateway. We have an app registration in Azure Active Directory to allow us to sign into our app to place orders. We've configured redirect URIs for Spring Cloud Gateway and API Portal that are running on our Azure Spring App Service instance. Let's configure single sign-on for the apps that make up our fitness store. For that, we'll update Spring Cloud Gateway with the values from our app registration. And then we'll add a route config for the identity service to secure the login endpoint. We can see and edit the SSO configuration in the portal as well. And then we can go to our landing page to jump to the fitness store to make sure it's all still working. Let's log in. Login button. Since we're already logged into Azure, it's seamless. And we can click the login button again when everything comes back up, and you can see my name logged in. We've added Active Directory to our app architecture. We have a key vault to hold all of our fitness store application secrets. All of the app secrets are here, such as database information that the apps need to know, credentials and connection strings, information monitoring credentials and SSO URIs. For all our apps, we've granted access to read these secrets directly from Key Vault, where no one else can see them. Let's tell the catalog service to load secrets directly from Key Vault. That's all it takes. We can now open the portal and go to the store and see all the items in the catalog retrieved from that database. We've configured the apps to load secrets from Key Vault, where only the apps can load secrets directly into memory with no code changes or recompiling needed. Only the apps can see secrets, no one else can. This is zero trust in action. Right now, everything is up and running, but when something isn't working as developers, we need logs. This query shows error logs and exceptions for all our running apps that make up the fitness store. We can refine that by lots of different criteria. For example, here are all the logs for the catalog service. We can look at logs for the service components as well. Let's look at the Spring Cloud Gateway logs. This is where we can debug our route configurations, and we can see that I need to look at an exception later. If our apps are having trouble communicating with each other, we can troubleshoot app registrations in the logs for service registry. There are many more options to build queries, and it's easy to do. Just tab complete your way through the query builder. Now, if you're an engineer like me, you also don't want to go to a portal to see logs all the time. You want to tail logs from the command line for your running apps. You can do that like this in the AZ CLI. And here are our logs. Let's look deeper into our fitness store application with Application Insights. By looking at the application map, you get a 10,000-foot view of all the components and their dependencies. Let's take a closer look. This is the identity service, the order service, and the payment service. You can scroll down a little to see our catalog service over here. There it is. And back up to see the cart. There. Now for our components. This is Active Directory. You can see the login URL on the side. Here's our key vault, where you see the calls for secrets. Scroll down to find service registry. It's right here. And we can take a look at Postgres. Let's go into Postgres to see how our queries perform. Here are all the calls that translate into SQL calls. And the individual queries are right here. Before we get into those individual queries, let's look at all the calls in the application. Let's click on the product call to query the catalog. Here it is. And we can drill into Postgres. And by clicking over here, we can see the exact SQL query for products that originates from Spring Data JPA. That's super cool. We can also see the exceptions, and you can drill into those to see stack traces just like we saw in the logs. As requests are coming in, we can watch them with live metrics which have less than 1 second latency. Here are all the calls going in, and all the servers powering the fitness store over here. We just monitored our apps and dependencies from end to end, all of this without writing any Java code. All these cool charts come by default. We used Application Insights, Log Analytics, and Azure Monitor, but you can also turn them off if you want. You can monitor end-to-end using entity monitoring tools and platforms of your choice, such as New Relic, Dynatrace, AppDynamics, Elastic, or Splunk. Let's go further and automate our work with GitHub Actions so that we do not need to build and deploy apps by hand. Here you can see a provisioning workflow, and we've set up a workflow for each of our apps in our fitness store and a cleanup workflow to deprovision all the things. Let's zoom into the provisioning workflow. We're provisioning everything with Terraform here, and we can see all the steps involved, such as setting up Terraform, creating up an instance, setting up the extension. Scroll down a little bit to see all the different components being configured, such as app config service and Tanzu build service. Let's take a closer look at configuring Spring Cloud Gateway. Scroll down a little bit to get to it. Here it is. So if I click into that, we can see what's it doing. It's assigning an endpoint so that we can reach our Spring Cloud Gateway from the outside world and see our application. Now that provisioning is done, let's look at deploying the catalog application. We can see the build succeeded, so let's look at the steps. Here's the setup of JDK 11 over here. And we can look at the setup of, say, the Azure Spring extension right here. Nice and simple. And here are the deployment logs over here. As we scroll down, we can see Tanzu build service starting up here. Scroll down and start seeing our build packs being applied. And in a moment, we'll see Gradle. Now, all these things the logs are all right next to the source in GitHub, so you can find them when you need them. They're linked to the commit they're based on. You just saw us automating everything from idea to production using GitHub Actions. We use pipelines to provision, build, and deploy. You can have any number of pipelines just like this. You can automate end-to-end using any tools and platform of your choice, because everything can be done from the command line. So we started from scratch, deployed apps connected to a database, configured Spring Cloud Gateway and single sign-on, managed secrets using Key Vault, monitored end-to-end, and automated end-to-end. Everything I did today is all available on GitHub, including step-by-step instructions to deploy everything here. All you have to do is go to aka.ms/fitness-store. I'm Candace Quates, and this has been a demo of Azure Spring Apps Enterprise tier.
Candace, amazing demo. Thank you. You saw the power of Azure Spring Apps running on Kubernetes, but you do not have to learn or manage Kubernetes. Everything is taken care for you. Apps that you deploy are portable. You can deploy the same apps anywhere, any cloud provider, or any on-premises machines as well. You can secure your apps using virtual network, configure single sign-on for users using your preferred identity provider, including Azure Active Directory. You can manage app secrets using Key Vault. You can define roles and responsibilities for actions on Azure resources to match your team structure using Azure role-based access control. You can secure communications end-to-end or terminate at any point of your choice. Your container operating system, your JDK, and monitoring agents are always up to date with auto patching. You can drive maximum usage of resources using autoscale. You can monitor end-to-end using any tool and platform of your choice. You can automate end-to-end from idea to production using any automation tools and platform. You can leverage existing investments. No need to change, particularly your existing investments in network, monitoring, automation, identity providers, on-premises systems, tools, and libraries. You can see we are super busy building lots of stuff, have several things in preview, like bring your own containers, bring your own storage, user-assigned identities, and service connector. Soon, all of these will become generally available. WebSocket and HTTP 2 support. Many customers have requested. They're on the way. More monitoring features like app live view, enriched self-diagnosis, particularly for app-level errors. All of those are coming. We are expanding the service to multiple European regions in Switzerland and Germany. To make it easier to get started and accommodate smaller projects at lower cost, we will further reduce the size of the base unit. We talked a lot about Spring Apps today. Next, we have Jason, who will dive into other Java app types, including Java EE and Jakarta EE.
Thanks, Asir. Hi, everyone. My name is Jason Freeberg. I'm a product manager on Azure App Service. If you're not familiar with App Service, it's a managed platform for hosting web and API applications with features for easy code deployment, auto-scaling, monitoring, and more. All of these features improve developer productivity and enable organizations to achieve more. With App Service, you can deploy your application code to a container that the service will manage and update for you, or you can deploy your own container and the platform will run it just the same. App Service provides APIs, plugins, and extensions to deploy from the Azure CLI, IntelliJ, Eclipse, Maven, GitHub Actions, Jenkins, and more. App Service also has a feature called deployment slots, which are staging environments where you can safely deploy and test new versions of your application or test new configuration changes. When your tests are complete, you can swap the staging and the production slots, and App Service will scale the staging environment to match your production footprint before routing traffic to the new environment. And speaking of scaling, App Service has support for auto-scale rules based on metrics like request counts, resource consumption, or simply by the time of day if you wanted to scale up during business hours and scale back down during off hours. When you're scaled to multiple instances, App Service's health check feature will reroute traffic away from any unhealthy app instances. And if those workers remain unhealthy, the platform will recycle it in an attempt to fix the application. When your applications are in the cloud, auto-scaling and handling thousands to millions of requests, monitoring becomes incredibly important. And thankfully, App Service integrates with Azure Monitor to provide a turnkey monitoring solution for your Java apps. That means no code changes are required. Enable application insights from the Azure portal or the CLI, and App Service will attach the monitoring agent for you. When enabled, metrics will begin flowing to application insights, and there you can watch for live metrics, view an application map of your entire deployment, and you can also set up alerts for scenarios like slow or failing requests. And then you can use application insights to diagnose and solve the issue. App Service has support for all types of Java applications. If your app runs as a jar with an embedded servlet, you can run it on the Microsoft build of the OpenJDK. On the other hand, if you have a war application, you can deploy that to the managed Tomcat runtime on App Service. And we recently partnered with Red Hat to offer JBoss EAP on App Service for your Java EE or Jakarta EE applications. This is the only managed service for EE applications in the entire world. JBoss EAP on App Service is a first-party offer with Red Hat, which means that you get integrated technical support from both companies without having to secure an entitlement from Red Hat. Since it's offered on top of the App Service platform, all of the features that I mentioned earlier, like easy deployment, auto-scaling, and monitoring, are also available for JBoss EAP. And we recently shipped support for clustered deployments of JBoss EAP on App Service. So if you have a Java EE application that uses features like stateful sessions, distributed transactions, high availability, or similar features, you can migrate those applications to JBoss EAP on App Service without refactoring. Speaking of migration, I'll hand it off to James Faulkner from Red Hat to show us how to migrate a Java EE application to JBoss EAP and then deploy it onto Azure App Service.
Thanks, Jason. So Jason showed you just how easy it was to run Java applications on Azure App Service. And I'm going to show you how equally easy it is to run your Java EE and Jakarta EE applications using JBoss EAP on Azure App Service, which is a fully managed Jakarta EE platform with integrated support from both Microsoft and Red Hat. let's get to it. So we'll start here on the Azure portal, and just like Jason had created the web app earlier, we'll go ahead and create a new web app, but in this case, we're going to choose our JBoss EAP deployment. We're also going to try the Web Plus database experience because we are going to need a database because this app does use persistence. So I'll go ahead and put it in my demo resource group, and we'll give it a name, JHF Web App. And here we'll choose the runtime stack. We'll choose our Java 11 stack, and then for the runtime, we're going to pick JBoss EAP7 here. We're also going to choose to create a Postgres database, and we'll just give it a simple name of JHF-Postgres, and we'll go ahead and create that. So what's that's going to give us is a basic Azure App Service using JBoss EAP as the runtime. And once it's deployed, you can see if I browse over to it, you can see it's the basic landing page. We don't have our application deployed to JBoss EAP yet, but we'll get to that next. So the application we want to deploy, I've loaded it into VS Code over here, and it's a standard Jakarta EE application using things like REST and CDI and EJBs and persistence, but it also uses proprietary WebLogic interfaces as it was written originally for WebLogic. So we want to run this tool on JBoss EAP on Azure App Service. So we're going to use a tool called the Migration Toolkit for Applications from Red Hat, which allows you to analyze and automatically inspect the code and provide guidance on how to migrate that. So it also has integration with VS Code. So there's an extension for it, which we will run here. So I'll just right click here and start a new configuration for running this tool. I'll choose my source code. So I'll browse to the source directory here in my workspace. We have a target chosen of EAP7, which is the version on Azure App Service. And then we'll choose the source and we'll mark that as WebLogic. So with that done, we'll go ahead and run this tool and see what we get here. So it takes about 30 to 40 seconds. We'll just wait for it to finish. Okay, the analysis is complete, and we'll see a bunch of stuff on the left here, but we also see this button on the bottom right, Open Report. So this is going to open the report that it generated, and you can see our application here. It has this thing called story points, which are a relative level of difficulty. Pretty easy, 11 is pretty small, but if you click into it, you can see the individual types of issues across the different Java packages, whether they're mandatory or optional. And then on the Issues tab, you can get specific detail about everything that it found, including pointers to documentation or potentially suggesting of line changes. So also due to the VS Code integration, you can see here, it also marks those same issues in a kind of a browser here. And if I right click, or I go over to Startup Listener, in this case, it shows the different issues that I found. You can see the exact same kind of details directly in your IDE that you could see in the HTML report, and it also marks the code so you know exactly where to go and what to change. So I'll go ahead and make those changes, just a few minor changes here to move to standard APIs away from the proprietary WebLogic APIs. And with the code changes complete, I'll go ahead and rerun the tool just to confirm that I correctly migrated the application, and we'll wait for that second run to finish here and check our work. And indeed, you can see my application has been successfully migrated from WebLogic to JBoss EAP with 0 story points remaining. So I'm ready to compile and deploy my application to App Service. But before I do that, I need to configure JBoss EAP to talk to that database I created earlier. So to do that, I have created an automatic CLI file, which can be invoked as part of the startup. Due to the ephemeral nature of App Service, I could go in and edit config files and make it work on one instance, but as soon as that reboots, that gets wiped out. So we really want to create that automation. So it's about 5 or 6 lines of JBoss CLI here to create the necessary, add the database driver and create the data source, which can happen every time the server is rebooted. So I have a simple startup shell script here, a hook, which will automatically deploy EAP or automatically create the data sources in EAP every time it starts up. So with these files put in place on my app service, I can then now go ahead and repackage my application using simple Maven command to build the WAR file, and then using the Azure plugin or Azure extension for VS Code here, I can right click on my web app and say deploy to web app, and I can browse and find my WAR file, which is created, which is under the source directory here, the target directory. So target, and then root.war is the one I want to deploy. And yes, I'm sure. And then I'll go off and deploy that automatically through my IDE. I'm not going to wait for this to complete. It takes about 40 to 50 seconds to deploy and restart the service and initialize the application. So I've already created a second version of this application over here in Web App 2. So I'll right-click and say Browse Website, and I should see my retail application properly hooked up to my database and providing me the information that I'm looking for. So I got my application deployed to EAP on App Service, and now I want to configure it so that anytime I make a change to the source, it automatically gets rebuilt and redeployed to EAP on App Service. We'll use GitHub Actions for this. The nice thing is EAP on Azure App Service has a nice integration with GitHub Actions. So back over in the Azure portal on my web app screen, I can go over to Deployment Center and configure the source code to my application, which is on GitHub, to automatically rebuild and redeploy every time a change is made on a particular branch, or we can also get fancier with some other CI/CD options here. But I'll just configure it to build every time there is a push to my new repository here. So I'll select the repository. It's called Workshop JBoss Migrate JBoss EAP on App Service, and then I'll just choose the main branch here. It already knows the stack I'm using here because I configured it initially when I created the app service, so I can see what that file is going to look like. If I want to see the actual GitHub action that's going to be created with the jobs and steps and so forth, this will automatically rebuild my application, upload it as a WAR file, and deploy it to app service using a secret that's established as part of this integration, so I don't have to reveal any passwords. So I'll go ahead and click Save here. What this is going to do is create that GitHub action file in the GitHub repository, which is automatically going to trigger it. In fact, by creating it this first time here, it'll automatically trigger that deployment as well. So if I head over to the actual main or the repository here and head over to Actions, you'll be able to see this new action starting here. So we're not going to wait for that to complete. What we're going to do is actually push the code that we've changed so far into our repository and get that code up and running in our production scenario here. So you can see a number of changes I made as part of that migration. And so let's just go ahead and push those in. So I'll change this to migrate to JBoss EAP and Command Enter. Yes. And I'll go ahead and click the sync button, which will then automatically push those up to my repository, which will then again trigger that GitHub action to build that. So once that one is complete, we'll see another action start running here for my merge that I just did here a few seconds ago. And once that completes, then my application will be again up and running, but in an automated fashion. So anytime I make a change, it's going to push that code automatically and rebuild it and redeploy it to app service using that integration. So a nice CI/CD option here for your EAP apps when you're deploying them and using app service to run them in production. So the last part of this demo, I'm going to showcase the integration with Azure Application Insights for observability, which is really useful for pinpointing performance bottlenecks or identifying bugs across distributed systems. We're going to add a simple counter here using a popular library called Micrometer. So we'll add a counter, and then every time our products list is accessed, we will increment that counter. So I'll add the counter here, call it get product counter, and then I'll add the increment of that every time that API is called. So with that API in place, I'll rebuild the application just to make sure it does still build and didn't break anything, and push that code up to GitHub, which will then trigger our new GitHub workflow. You can see there the add counter that I just integrated. And I'll head over to Application Insights now that this has been deployed. Azure Application Insights provides this nice dashboard for standard metrics, but we can also find our custom metric. In this case, we're going to look for our get product counter and be able to see that there not only do we get the automatic integration with standard JVM metrics, but we also get our custom metrics. So to wrap up, it's easy to run Java applications as well as Jakarta EE applications using JBoss EAP on Azure App Service. I hope you enjoyed the demo. Back to Balin to wrap us up.
We are really excited about these partnerships with VMware and Red Hat and the value we are able to bring to customers together. Azure is the only cloud to offer platform services specifically for Java, in addition to fully managed Kubernetes services. In addition to covering the breadth of the Java ecosystem on Azure, we offer differentiated capabilities that enable you to deliver features faster with confidence. Now I want to share a few things to get going with Java on Azure. Many enterprises already have existing Java workloads that are great candidates to migrate to the cloud from on-prem virtual machines. We are broadening the support for different types of Java applications in Azure Migrate Hub. The Azure Migrate Hub enables you to discover, assess, and migrate applications and their dependencies seamlessly. At-scale assessment in preview since 2021 allows bulk assessment of web apps and provides a list of apps that are ready for migration. It suggests destinations in Azure based on the assessment and provides monthly cost estimates. And at Build, we are excited to announce at-scale migration, which enables bulk migration of web apps to Azure. You can also plan your migration and ensure zero data loss through built-in testing capabilities. The Azure Migration and Modernization program provides step-by-step guidance for specific migration scenarios, enabling you to incrementally migrate and modernize your mission-critical applications. Through a combination of technical training, resources for best practices, and hands-on support from Microsoft engineers, this program has helped customers confidently migrate their Java apps. It makes it seamless for customers to use various resources, such as the well-architected framework and Azure landing zones, to accelerate their migration and realize cost savings sooner. So, how can you get started with Java on Azure? Check out our quick starts to get going with the different options for running Java on Azure. We also have detailed Java-specific documentation for all the services and capabilities that we looked at today. And for a structured interactive learning experience, check out our Microsoft Learn modules. We can't wait to see the amazing applications you will build with Java on Azure.